So first we will start with the concept of regression. Now to understand and learn that concept, we will be using this data set called as windmill. Okay. Now what do we have in this data set is, let's connect to it first. It's an Excel file. So we'll choose Excel workbook option and connect to the windmill data. So we have details about the power generated across different windmills in a power plant, depending on the wind speed. So the data about the wind speed in the locality and how much power generation happened is what we have. Okay, we need to use this data and we need to do some prediction on top of this data. Okay, so we will load the data into Power BI. Now, see what we are trying to achieve over here is, when I say regression, we are basically doing prediction analysis on the data. Okay, so when we say regression, we are basically performing prediction on the data. Now, prediction in the sense, whenever we are given questions where we have to estimate the value of the output given the input. Prediction is what? If we have to estimate what will be the value of the output variable given the input variable information to us. Okay, what will be the value of the output given the input? Now, output is generally denoted with the character Y. Okay, and the input is denoted with the character X. Okay, so for example, what will be the profit given sales? Okay, what will be the weight gain by a person given the calories consumed? Okay, or in our case, what will be the power output in a power plant given the wind speed in that locality? So what we are trying to do here is we are trying to express the output Y as a function of the input X. So this is the dependent variable. So profit here is going to depend on sales. Sales is the independent variable. The weight that I will gain is going to depend on the calories that I will consume. So the weight gain is the dependent variable. It would depend on the calories that I'm going to consume, which is an independent variable. I can eat how much ever I want, but based on what I eat, my weight will be impacted, right? So wind speed is the independent variable, whereas power generation will depend on the wind speed. Power generation will depend on the wind speed. Okay. So what we are trying to do here is express Y as a function of X. And we are going to perform linear regression for this. Linear regression is what we can do in Power BI. So that is what we will do. Okay, to do this, to express Y as a function of X. Whenever we are given questions in this format, where we have to estimate, predict the value of the output given some input. Okay, first thing we need to check is whether or not there is a proper correlation between these variables. There has to be a correlation and it has to be strong enough. Only then we will be able to predict. Otherwise, even if we do the prediction, it will not be accurate. Okay, it will be far away from the accurate value. For example, so I need to first check the correlation. Okay, to answer questions that are framed like this, we need to first understand whether or not there is a correlation between the variables. To perform correlation analysis, to check the correlation, the chart that we need to know about is scatter plot. Because once we create a scatter plot, it tells us about two things. It tells us about the direction of the relationship and it tells us about the strength of the relationship. Okay, direction is, it could be positive, overall direction in which your data is moving. Okay, it could be negative. There could be no relation. Depends. It's not necessary that all the time there has to be a correlation, right? If someone asks me, predict the weight gain predict the weight gain, I will give you the wind speed details. So if someone says predict the weight gain, when you are given the wind speed in the locality, there will be no relation between weight gain of a person and the wind speed in the area the person lives. It would depend on how many calories we're consuming and how much are we burning out. Correct? It would not depend on the wind speed in our locality. So in such cases, we cannot perform prediction. It wouldn't be the right thing. Okay, so to understand whether or not there is a proper correlation between the variables, first thing is to create a scatter plot. Now, when we create a scatter plot, we understand about the direction and we can understand about the strength. Strength, it could be a strong correlation. It could be of moderate strength. It could be weak. Now, if it is a weak correlation, we will not proceed further. We will not do any regression analysis on that. We will stop there until it is not a strong correlation. It is very weak. So even if we do prediction, it will not be correct. Or if we feel there is no definite relation between them, then also we will not perform prediction on that data. Only when there is a proper correlation, whether it is positive or negative, and when the strength is strong or at least moderate, we will proceed further. Okay. So simply by looking at the chart, we can figure these things out. So when we create a scatter plot, okay. When we create a scatter plot, it would take a shape like this. Okay. So we will plot the input variable data that is already given to us along the x-axis. We will plot the output variable data along the y-axis. So if it is power output and wind speed, power output will be the y-axis, wind speed will be the x-axis. Then using the existing data, when we plot them in this xy coordinate plane, okay, every data point has an x coordinate, has a y coordinate, right? So when we plot it, if we see that overall it is going upward, we say there is a positive correlation. Here also it is a positive correlation. Here we can't really determine the direction in which the data is moving, right? In this case, there is no correlation. I don't know whether it's going up or down. Here there is a negative correlation. This is negative correlation. So for example, let's say I have discount here and I have profit here. So if I'm offering 10% discount on a product, I might make a very high profit. Same thing if I offer 20% discount, I'm compromising on the profit. At 30% discount, the profit will further come down. At some point, it might even go into a loss. So increasing the discount will reduce the profit. There is a negative correlation. Okay. Or for example, the concept of depreciation, depreciating value of an electronic good. Let's say this is the number of years that I'm using a product. Let's say phone, let's say my TV or iPhone. Let's say I've used an iPhone for 1 year. The resale value will be pretty high. If I've used it for 2 years, it will come down. 3 years, it will further come down. 4 years, 5 years. At a point, people will say, no, thanks. It's not of any value to us. We'll not buy. So depreciation, the value is depreciating as the number of years pass. Okay, of electronic goods. So there could be a negative correlation also. Sometimes when you have seasonal data, it could be curvilinear as well. Okay. So first we need to check the correlation, which can be done by creating a scatter plot. Scatter plot will tell us about the direction and it will tell us about the strength. So if you see all the data points together going in a specific direction, we say it is a strong correlation. We put a trend line actually. We put a line that is called as a trend line. We put a trend line. Now, if we see that some data points are near it, some of them are a little scattered away, then you can say this is moderate correlation. Here, There is no correlation. They're widely scattered. We don't know. This is no correlation. This is moderate. This is strong. This is also strong. Okay, this is weak. This is a weak correlation. This is weak. So when it is weak, we will not perform any prediction on such data. So generally, by looking at the chart itself, we will be able to understand about the direction and about the strength of the correlation. Okay. So once we know the direction and strength visually through our visual analysis, just by looking at the chart, once we are able to determine the direction and we are able to determine the strength, we can decide whether or not to proceed further and perform regression on that data. Okay. So when you perform regression, you will get you're supposed to create one equation. For linear regression, the equation is y is equal to mx plus c, where m represents the slope of the data, okay, slope of that line, and c represents the y-intercept, the place where the line will go and intercept with the y-axis, where it will touch the y-axis. Okay, so we are going to create a scatter plot, right? We are going to create a scatter plot with all the data points. Then we will put a trend line. Trend line, after putting this trend line, the slope of the line has to be computed and the y-intercept. Suppose this is touching the y-axis here. Suppose this is the line. So this point where the line intercepts with the y-axis is called the y-intercept. Slope is the inclination of the line. Okay. Now here, we need to create this. For regression, we need to create this kind of a formula. But even before deciding whether or not we should proceed with the regression, we need to create a scatter plot to understand it. Okay. Now, we are connected to windmill data. So what we have here is, as I was telling, power output and wind speed across different windmills. So we will create a scatter plot, which is over here. Scatter chart or scatter plot, you can call it anything. Before the pi, you will find it. When you click on it, it will be loaded into the canvas, right? Once we click on a visual, it gets loaded into the canvas. Now I need to fill data into this visual. I need to put data in here. Okay, so I'm creating a scatter plot and I need to populate the data. So what is the question we are trying to answer here? We would like to check what will be the power output given the wind speed. So what is y? Power output, the thing that you're trying to determine. So this is my y. And what is my x? Wind speed, the value that will be provided, and then we have to estimate the power generation. Okay. So this is a chart where you have to take the output onto the y-axis, input variable to the x-axis. So in this scatter plot, you can see x-axis is there and y-axis is also there, right? So I will bring wind speed into the x-axis and I will take power output into the y-axis. Now it did not give us a scatter plot, but it's just giving us one data point. The reason for this is the aggregation. It is the summation of the entire data present in the wind speed column, summation of the data present in the power output column. So when we go to data view, it summed up all of these numbers. It summed up all of these numbers and it's giving us a data point. We should not summarize this. Okay, from every row, the wind speed and power output should be taken and plotted. So we need not, or we should not summarize this data. We should not summarize. So how do I prevent it from getting summarized? I will click on this arrow mark, select the option, don't summarize. For both the fields, I'll click on the arrow mark, select the option, don't summarize. Okay, I hope you all understood till here. Can you all please create the chart till here? Click on the scatter chart, bring power output to y-axis, wind speed to x-axis, and select the option to not summarize. Okay, I hope all of you are able to create it. Now, by looking at this, we can understand the information, right? We can understand that it is clearly a positive correlation, right? Increase in the wind speed will lead to increase in the power output, at least to a significant extent. We do have some data points which are not following the pattern. We do have some values here that no matter what's the wind speed, the power output is very close to zero. Okay, we have this and we have this, but overall we can see there is a positive correlation, and it seems to be like a strong correlation also, all the data points going together in a specific direction. So through our visual analysis, we understand that this seems to be good data on which we can perform regression. It seems like a strong correlation, and it is definitely positive. On the scatter plot, you can go ahead and under analysis of the scatter plot, we can put the trend line. Okay, we can turn on the trend line, which comes as a dotted line by default. So trend line is basically the best fit line, a line that is going through as many data points as possible. Here, Power BI will only give us the trend line, but it will not give us the equation. Okay, unlike in Excel where we can get the equation, here we will not get the equation. Only thing it will give us the trend line. It will not give us the equation y equal to mx plus c. It will not help us understand the strength of the correlation. All this will not happen automatically. We need to compute it. Okay. So first step towards prediction is to check the correlation, which we did. We can understand that it is a strong correlation and it is positive. This is one aspect. Now that we understood this data is good enough, we need to perform regression on this data. So that would be the next step. So in order to perform regression, first, let's create one table. Okay, all of you can click, or you can go to a new page. In fact, you can call it regression. Okay, you can go to a new page and you can click on this table. Please do this till here. All right. Now into this table, we are going to bring the wind speed. Given the wind speed, whatever is the power output, and we shall not summarize it. Let's look at all the values that we have for wind speed and power output without any summarizing. So for different wind speeds, what is the power output is what we are seeing. Okay. We have all the way up to 18 meters per second also, where the power generation happened was 29 megawatts. Okay, at 18 meters per second wind speed, 29 megawatts of power generation happened. Then we can see some values like this, right? 22 only here 29. Maybe different factors would be influencing, right? Maybe the location of that windmill. These things have influenced the power generation. We don't know. So for now, this is the data we have. Now, we need to first create one table with which will generate the regression values, which will generate the predicted values. Okay, we need to create a table for that. So how do we create a table? We know how to create a new measure. We know how to create a new column. Today, we are going to talk about creating a new table. Okay. I hope till here you are all with me. Anybody who needs more time here, you let me know. So first is plot should be done. And now we just created a table with the existing data, but we are going to create a table in the model now. Okay. So we'll go to modeling and we need to create a table under data modeling. So I'll go to new table. New table over here. Please go to modeling and create, select the option table. You can see another table is coming into our data model now. Okay, sheet 1 is one query. Now table is coming as a data model. So I will call this, okay, let's call this power output table, something like that. Okay, So the function that will help us to perform regression, prediction analysis on the data is line st. So what will line st do? It will use the least squares kind of an algorithm, okay, where it will come up with the data points. Okay, now this one moment, let me do it. Now we can see it. So it uses the least square method to calculate a straight line that best fits the data, then returns a table describing the line. What will be the equation? Y is equal to mx plus b or c. In some country, in India we call it c. In other countries, I think it's called b. Basically, it is the y-intercept, the place where the line will go and touch the y-axis. Okay, the intercept. So y equal to mx plus c. In this format, we will get. What are the inputs that it expects? It expects column Y and column X. So column Y is what? The power output column, comma, column X is what? The wind speed column. And then we can close it. Okay, can you all please create the table? Power output table will be created when you do this. You can see the slope of the line is calculated, intercept of the line is calculated. That is M, this is C or B, whatever you call. The coefficient of determination, which talks about the strength of the correlation. Okay, a lot of other things which data scientists would use in their analysis is generated by the line st function. Okay, please create this. So I hope you all understood this. It is taking the power output and the wind speed, the Y and the X, and it's going to generate all the fields which we need, which in fact, many more than what we need for creating that, for performing regression analysis. Okay. So once you do this, the table is ready. We know what is the slope. We know what is the y-intercept. So just to show you, let me click on slope. Slope is 2.4 and the y-intercept means the place where the line is, no? This is 0 on the axis and this is my trend line. So if I were to extend this line, like that, where will it go and touch the y-axis? Below 0, negative 6.45. There it is going to touch. Okay, this is 5. It will touch somewhere over here. So everything is computed. Now, I was talking about the direction. So we understand it is positive. There is no doubt about it because the slope is positive. What is our slope over here? M is equal to 2.24 something. It is a positive correlation. It is a positive correlation. And about the strength, how do we know about the strength? This looks like a strong correlation. Simply by looking at the chart, we understand it. But over here, we have something called as coefficient of determination. Okay, this coefficient of determination field will tell you about the strength, which is 0.96. Okay, so if the coefficient of determination is greater than 0.8, it is considered to be a strong correlation. If it is from 0.65 to 0.8, then it is considered to be of moderate strength. It is considered to be of moderate strength. Okay. If it is less than 0.65, then it is considered to be a weak relationship, and we should stop there. When we come across less than 0.65, a weak correlation, then we will tell that it is a weak model, so we will not perform prediction on this data. Okay, so this thing talks about the strength. This is the slope and this is the y-intercept. These are the three fields that we need to check. Now I will not put that in the table. Let me remove them. That was just to show you all what are the values. Now that we know this, we need to build our equation. What is the equation that we need to build? Y is equal to mx plus c or mx plus b, whatever. Okay, so I need to build this. I need to build this regression formula. So how do I build that formula for regression? I'll create a new measure over here. And this power output table itself, I'm going to right click and create a new measure. Okay, can you all please select the option to create a new measure? Okay, so what is the new measure? It is going to contain the power output values. It's going to contain power output values in it. So that is my y. Okay, y. The name of y is power output values is equal to mx plus c. M into x plus c, or it can also be called b. C or b, anything, depends on the country that we are in. Okay, so m is how much? It is over here, slope. Into the wind speed values that I have, plus c. C is the y-intercept. Okay, so you can either hard code the slope and the y-intercept values. You can say 2.24 multiplied by the wind speed values and all. We can do that, or we could use these variables. So this is a new measure that we are creating. Measure will only take aggregated values. So just for the formula to work, we must use sum. So summation of the data that I have in the slope field, m, multiplied by summation of the data that I have in the wind speed table. Okay, x. X is what? Wind speed. Mx. Mx plus c, no? So m into x is done. Then plus c. What is c or b? The y-intercept. Intercept. So sum of the data that is there in the intercept column. Like this, you have to build the formula. This is slope, this is x, and this is the intercept, c or b, whatever we refer to it as. Okay. So why am I using sum here? Simply because this is a new measure, and measure will only accept aggregations. It will accept only when you give aggregation. So sum of slope, sum of wind speed, sum of y-intercept you should put. Okay, please create this formula. Okay, I hope it is clear. I hope this formula is ready. Now, this is basically for us to check whether the equation is good or not. So create it. After creating it, you can load this data into the table. So select the table and you can bring this power output thing that we created over here. So these are the values that we have obtained by performing regression analysis on our data. This is the actual value. Now, because the slope was negative here, the values are way off from what actually happened. But as you go towards the upper side, right, you can see this is the actual power output when the wind speed of was 16.35 meters per second. And this is what the model gave us. The regression model gave us pretty close. Right here also 29, 34, 28 is what happened. 27 was the predicted value. 27.5 was the actual power generation which happened. 27.77 is what the model is giving us. The regression model gave us this. So you can see it is pretty close. Some places it is a little way off. Maybe some factors over there are different because these windmills are situated in different locations. So it could be maybe in that location there is lesser power being generated than what we have expected. So anything could be the reason. So mostly the model, whatever values it is giving, they are pretty close to the reality. Okay, so whatever model we created on this data, which has a strong correlation, it is working good. So this is for existing data, only for us to check whether the values are close to what we have estimated. So this is with existing data. Now we need to do this for other values. We need to predict it for other values. Okay. See, using my existing data, I can answer certain questions. If someone asks me, what will be the power generation when the wind speed is 13 megawatts? I have that scenario in the past. In the past, from my existing data, when the wind speed is 13 meters per second, 23 megawatts of power was generated. Okay, and my model is also telling me almost the same. 22 to 23 megawatts of power generation will happen when your wind speed is 13 meters per second. So 22 to 24 megawatts of power generation is likely to happen. If the wind speed is 14 meters per second, then I can see it about 25 to 27 megawatts of power generation will happen. Correct? If someone asks us, what will be the power generated when the wind speed is 20 meters per second or 30 meters per second or 40 meters per second, we cannot predict because we have data only up to at most 18 meters per second. So when it is 20 or 30 or 25 or 40, we don't know what the power generation will be like. And that is the whole purpose of building a prediction model, building a regression model to be able to predict for values that have not yet occurred. Correct? So let's say the question given to me is to figure out by building a regression model or a prediction model on the data, I need to figure out what will be the power output when the wind speed is 30 meters per second. So in order to answer this question, first we created a scatter plot to understand the direction and the strength. We understood that it is a strong correlation and it is positive. After that, what did we do? We built the linear regression equation, y is equal to mx plus c. But we are using existing x values in this equation, right? We use the wind speed present in our data connection. Using the existing values only, we built the model. So for new data, it is not going to help us. It is just to cross-check whether the values are close to the reality or not. Now I'm going to come up with the formula, same y equal to mx plus c, but I'm going to put in 30 meters per second in my formula. Okay, because I need to know the power generation when the wind speed is 30 meters per second. Okay, so how to build that? Sales analysis you can do with Superstore. Profit versus sales you can create. Same method. Okay, I'll do it. I'll show you one more. Okay. Yeah, done. Okay, so now I'm going to create a new measure which is going to give me the power output, power generation, given the wind speed, right? So wind speed given the thing. So what is my slope? M 2.24 multiplied by what is the x value that I'm trying to predict for 30 meters per second, plus what is the y-intercept we have? Negative 6.45. Correct, finish. So at 30 meters per second, what will be the power generation? Is what this formula will give me. Okay, and I'll use a card visual to see this data. At 30 meters per second, it is telling it will be 60 megawatts. 60 megawatts of power generation will happen. Now I have completely hard-coded everything here. So what if the question changes and they would like to know what will be the power generation for 20 megawatts? Then I'll have to open this formula, edit my DAX, and then this will change. Correct? So instead, how do we make this more dynamic? The X value, how can we take it in a more dynamic manner? So I'm going to create a what if parameter for this. So we'll go to modeling. We'll go to new parameter. We'll create a numeric range. This equation you all need not create. This we will do in a more dynamic way using the parameter. So for now, you all just go to modeling and create the new parameter for numeric range. So let's say minimum 20 to maximum 40 with a step size of 1. And this will be the wind speed that user will select using this parameter. Okay, user is going to give us the wind speed data. Through this parameter, they will input the wind speed. So based on the wind speed that they put here, we need to calculate the power generation. Okay. Okay, please create this. Create. Yeah. First you all create this, then I'll post the formula. Okay, so what will happen when we create the what if parameter? It will be added as a slicer to the page. Okay, please create it. All right. So now please create the new measure. This is our slicer where the user will select, let's say 20. Let's say wind speed is 20. Okay. User will put the information in this slicer. The wind speed data will be put in this slicer. Based on what wind speed is entered, we need to calculate the power. So let us create a new measure, everyone. Please create a new measure and the formula will be this. I will give you. So whatever name you have given to your parameter, which I call wind speed, that is what you need to put in this formula here. Slope multiplied by wind speed plus the y-intercept. Okay. I'm sending you all the formula. Here. The name of the measure is power generation. It is the slope 2.24 multiplied by the wind speed, which we are taking through the parameter, plus the y-intercept negative 6.45. Now it's completely dynamic now, right? It is completely dynamic because user will set up the wind speed value. Based on that, we are going to compute the power generation and show it in that card through this measure. Okay. Now you can cross-check the data in the card as you change the wind speed. Suppose I keep the wind speed as 25 meters per second, then the power generation will be 49 megawatts. If the wind speed is 30 meters per second, it will be 60 megawatts. If the wind speed is 40 meters per second, it will be 83 megawatts. Right? For different wind speeds, we are able to calculate what will be the power generated. This step is optional. This power output values that we created, right? That is optional. That is just to show you that the predicted values, which are coming as a result of the prediction model regression that we performed, and the actual values are pretty same. Means the prediction model is doing a good job. Okay, except for one-off cases. Okay. So now the actual purpose is to predict for something that is not already available with us, right? To predict what will happen when the wind speed hits 20 meters per second. In that case, what will be the power generation? If the wind speed hits 30 meters per second, then what will be the power that will get generated? So we are able to achieve this through our regression model, which is also called as prediction model. Okay. Now, very quickly, I will repeat these steps using Superstore data or maybe coffee chain, anything you can take. Okay, let's see the relation first between these variables. I'll take coffee chain. Okay, suppose we have to predict what will be the profit made by the business given the sales. Okay, so first step is to create a scatter plot to see the relationship between the profit and the sales values. And I am going to select the option, don't summarize, to see the relation. So this is the kind of data that we have. We do have some negative values and we have positive values also. Okay, so as the sales increases, the profit seems to be increasing. But there are some places where we are into losses. I'll do one thing. I'll focus only on, okay, this is my data. So it is definitely a weak relationship kind of a thing here, but just to give you a demonstration. So how is this going to help in sales analysis or whatever? So if you are asked to predict the profit made by the business, depending on the sales that they are planning to make. Okay, so first of all, what we need to create a scatter plot. Now I will perform regression on this data. So how do I perform regression on this data? I need to create a new table from my data modeling. I'll create a new table. Based on the sales data, we need to estimate power. So sales regression is what I will call it. Okay, is equal to. So line st, as I told you, is the function we will use. It will take two inputs, y and x. Y is the y is the profit, okay, which I am supposed to estimate given the sales. Okay, y is the profit to be estimated given the sales value. Filter only. There is no direct way of excluding outliers. You can make use of filter and remove it. So sales regression, this is ready. All right. Now I will create a table visual, okay, where we will input the profit and the sales without summarizing. So what is the profit given sales? We don't really see a proper correlation between them, but okay, this is what we have. So I need to predict, I will show you the slope. So the slope is 0.54 and the y-intercept is what we need to know, negative 42.46. Coefficient of determination tells you about the strength. Here we can see it is 0.64, less than 0.65, which means it is a weak relationship. But if you have a moderate or strong relationship, you can depend on those values. Okay. So now I need to predict the profit given sales. If I make sales worth so and so, what is the profit likely to be? How do I get that? I'm going to create a new measure. Okay, where I have to estimate the profit data, profit value given sales. So what is the slope here? 0.54 multiplied by whatever sales you are trying to input to check. Suppose the sales is going to be 200. If I'm going to sell products worth $200, then what is the profit I will make? Let's say negative plus y-intercept. Okay, did you all understand this equation? Y is equal to mx plus c. So slope I got through my line ST regression analysis, 0.54. Y-intercept negative 0.42.46. Sales that I'm planning to make is 200. So if I sell products worth $200, what will be the profit? Okay, if I'm selling products worth 200, what will be the profit? So it is created. Let's visualize it with a card by taking the profit value into it. So the profit is likely to be $64. If the sales is $200, profit is likely to be $65 is what it is telling us. Now that sales value, which I hard coded into the formula, you can make it dynamic by creating a what if parameter. So we could create a what if parameter. Sales value will be provided as an input over here. Let's say sales of 100 to, I don't know what is the highest over there. We will take maybe up to 2000. Okay, I don't think we have any product worth 2000, but we'll keep 1500. And I'm going to use an increment of 100. So 100, 200, 300, 400, all the way up to 1500. By default, let us give it some value, 500. And I'm going to see it is already here. So if it is 500, what will be this value? So how do I do that? I need to replace the hard-coded 200 with the sales input parameter that I created. So now what the user will be able to do is, user just needs to input the sales over here. Okay, if I'm going to sell something worth 1200, what is the profit I'm likely to make? $605. If I'm going to sell something worth 350, not possible because we use step size of 100, 300. What is the profit that I'm likely to make? 119. This is regression, which you can perform on any data. All the thing is you need to identify what is it that you're trying to determine, y, based on what are you trying to determine, which is x. Once you know what is your y and what is your x, like earlier we took power output and win speed. Now we have taken profit given sales, or maybe profit given the discount. If I offer so much discount, how much profit will I make? Okay, or marketing cost versus the selling price. Marketing cost versus sales. So if I increase the marketing cost to this, how much can I sell? If I reduce the marketing cost to this value, what will it be its impact on the sales? Any two variables between whom you want to perform regression, you can do this.